This week is going to deal entirely with quadratic equations. So what does quadratic mean? Skylar, you got something to do here. What does quadratic mean? Quadratic. We've been working on quadratics already. This is not new. What is when I stick the adjective quadratic in front of something? What does it mean? It does not mean 4. But I'm guessing you said 4 because you speak Spanish somewhat. No. When you think quad, you think of 4. But if you do speak Spanish, what's a cuadrado in Spanish? How do you say that in English? You don't know how you say cuadrado? Square. Thank you. Yeah, it is a square. So quadratic means square, but geez, in math, what does square mean? Like not the geometric sense of like the shape of square, but in algebra, what does square mean? To what? Skylar? Huh? Second power. Good. So just like last week, when you took a test on quadratics, you're still going to see a second power. And then I told you quadratic equations. So what else are you going to see this entire week? If we call it an equation, what does an equation have? An equal sign, right? So we've already dealt with this, but the only method that we used to solve quadratic equations before was exclusively factoring. In order to solve, we had to factor at some point. This week we're going to use different methods. Okay, the first one we're going to use is square root property. Okay, now square root property only works like, you know what, you might want to add this because I don't have this there. Assuming that this is a quadratic equation, this is what you're used to from before. What we're going to do today only works if b is 0, if there is no b term. Now this is assuming that one side is in simplest form, if there's no parentheses or anything, and you don't see a b, then what we are doing today will work. If there is a b, today's method won't work. This is something that can be used a little bit. We're working our way towards the end of the week to what is used the most frequently, which you might even remember from the first time you took Algebra I, which is quadratic formula. Did you get a note packet? Do you want one? You can still write. There's space to write on it with pencils and stuff, and we're gonna solve all these things. It's pretty wild. All right, so assuming that we look at the equation and we identify that this is a method that is viable, this is something that we could use. The steps are going to be a little bit different than in factoring. What was the first step when we solved by factoring? In order to be able to solve by factoring, what did we have to do first? Set the equation equal to 0, which means put all the terms on one side. With square root property, that's not the case. In this case, we're going to put anything that has a variable on one side, doesn't matter which side, left or right. And then all the constants. What's a constant? Well, no, you're thinking about coefficient there. Yeah. Number from a variable is a coefficient, which also starts with a C. Let's use some context. So if I'm saying all the terms that have a variable on one side, then if you're going to be on the other side, then you would. If all the variables go to one side, then what would end up on the other side? That's what I said, constants, but tell me what a constant is. The number that doesn't have a variable, a number that's by itself. Put that on the other side. Then what we're basically doing here, by doing it this way, is we're treating a quadratic equation as if it were linear, as if the square wasn't there. This is the way you've been used to solving equations. Like, we're gonna work on isolating the variable. Because that b term is not there, you should only be able to see one variable, and that one variable is being squared. So we're going to work on getting that variable by itself, which means that in order to get that variable by itself, eventually you're going to have to get rid of the square. If I have an x squared, in order for x to be by itself, at some point I'm going to have to get rid of the square. Usually it's at the end, but not always. Depends if there's a parentheses there or whatever. But that's where the title comes in, square root property. The big skill you're learning today is that if you're ever going to get rid of a square, first of all, what operation is going to get rid of a square? If we take, like, for instance, hey, how do you get rid of addition? You subtract. How do you cancel multiplication? You divide. How do you cancel out a square? Take a wild guess. The full title of the lesson. A square root, yeah. So not only are we going to have to take a square root, but what square root property says, is this also printed? Yeah. What square root property says is that when it comes time to take a square root, you need to be able to account for the positive and the negative roots. Like, this might not be the best graphic, it's just the only one I could find. But after you're done taking the square root, on the other side of the variable, on the other side of the equal sign, there needs to be a plus minus in front of whatever you get. And sometimes, in some cases, the square root will stick around. You will not be able to get rid of it. In some cases, you will. But regardless, there needs to be a plus or minus in front. You will see that plus or minus throughout the entire week. Even when we do different methods, you'll see that plus minus. We have to establish this today. Square root property. So here we go. First one. Is that the first example on your page 2? So what's the first step today? If we're going to use, like, what's going to allow us to use square root property? Notice how we do not have a b term. Well, I'm not going to use it, but if I were to ask you, what's a right now, what would you say? What's in front of x squared? A 1. And since there is, that's step 1, sorry. And if I were to ask you what's b, since there is no x term, if I were to ask you what is b, if I just finish writing for you, ax squared plus bx plus c equals 0, and I ask you what's b, it would not be 1, it would be 0. Like, everything that I said today is prefaced on the fact that there is no b. This whole x is not there. So, and then if I were to ask you what's c, what would you say? What's the constant there? Negative 320. So the entire reason why I'm able to use this method that we're going to do today is because there is no b. If there ever is a b, we got to find another way. Chris is looking for another way right now. He's going to let us know when he finds it. So now that we've decided that we can use square root property, what's the first step say to do? What does the first step say to do since we can use square root property? Yes. It does not say coefficients. Yeah, if there's any constants, move them to the other side, which in this case the constant is negative 324. So we're going to add 324 to both sides. Unlike factoring, where we would put everything on one side, this is going to be variables on one side, constants on the other, just like we did with linear equations. But unlike with linear equations, one thing we did not have to deal with is the square. In this particular problem, that's basically all we have to deal with. Because if that square was not there, then x would be by itself. It would be isolated. So what we haven't had to do until this point is to get rid of it. How do we get rid of it? What I told you was take the square root on both sides. The opposite of a square is a square root. On the left side, which is where the x is, we're going to get what we wanted, which is just an x. On the right side, what you get might vary. It's going to depend on the number underneath the square root. If that number is a perfect square, meaning you put that into your calculator, Jade, I believe you might have the only calculator in this, or there's two calculators. If you can do it on the calculator, great. If not, who remembers what you have to do if you can't do a square root in the calculator? You did it at the very beginning. Who remembers what we had to do when you couldn't do the number on the calculator with a square root? You did it at the very beginning in January when we first started this journey together. The tree, factor tree. But 324 does work. What is the square root of 324? You know where the square root button is? It's the one that looks kind of like a check mark. 18, okay. Sean says 18. But now wait, if you put that, you are wrong. At the very least, you're half wrong, because here comes square root property. Square root property says that in order for me to isolate a variable, I had to introduce a square root that was not there before. I'm the one that did that. That was not already in the equation. I'm the one that did that. And if you ever have to do that, on the very next line, on the other side of wherever the variable is, whatever's left, you have to put a plus or minus in front. So in reality, what are the solutions to this equation? There's more than one. Positive 18 and negative 18, which really means you should be writing a solution set. But this equation has two solutions, both positive 18 and negative 18. Fax machine. It's nicely done. Chris looks nice today too. He always gives me like a really nice view of the top of his head. Ooh, man. Well, Mr. Romero, look at that. After all that talking you've done, now you put a problem up here that's not even going to work because you said square root property only works when there's one x. And I see two different x's here. But they're both being squared. Even though they're on different sides, if I were to put them on the same side, which I'm about to, there still wouldn't be that b term. So if we're going to do square root property, we want to put all the x's on the same side. What would be the better side to leave them on? I still would prefer, you can actually get away without it, but I would still prefer to leave the number in front positive, just like we did with factoring. So what would be the better side to put the x's on here if I want to leave the number in front of it positive? The left would be better, sure. If I do minus x squared, I'll still end up with a positive in front. Well, all the x's now came to the left. So in order, we want to move the constants to the other side. So if all the x's came over to the left, what do I have to do next in order to put the constants on the opposite side? How? Yeah, minus 16 on both sides. So now I get 2x squared minus x squared gives me x squared. 7 minus 16 is negative 9. This looks now just like the last problem. So how do I get rid of the square? Yeah, the square root. We're going to perform square root property. So I will get the x by itself. I know that whatever I get on the other side, I'm supposed to put a plus or minus in front of, but try putting square root of negative 9 into your calculator. Tell me what happens. There's only two of you with a calculator here, so if we're gonna move this lesson along, you get an error. Yeah, the reason why you get an error is because there's no number that exists. There is no number that will make this equation true. So this equation has no solution. Right? No solution. Write the symbol for the empty set. No solution. Any questions there? Ooh, what's a little bit different here? There's a parentheses. And how you treat that parentheses, Kira, is going to determine how you can solve. See, the problem is you said something about distributing, but you still, even if you wanted to get rid of the parentheses, you wouldn't distribute because you have to deal with the square first. But that parentheses can be removed. The problem is if you remove it, you're going to get a B term. Remove it. What we would prefer to focus on now, if this is a method we're going to use, is in this entire equation, how many x's do you see? Just one. That's important. I prefer to leave it that way. So instead of trying to get rid of the parentheses, let's just try to eliminate everything around it so that I can get that, so I can isolate the x. If I could get rid of this 2, this -1, this squared, and this 3, if I could get rid of all 4 of those things, the x would be by itself. So let's see if we can do that. And then we know that whenever it does come time to get rid of the square, what's new today is that we're going to use square root property. So of those 4 things I have to cancel, which one am I going to get rid of first? What's the furthest away from the x that I would get rid of first? The 3. Yeah. What's the opposite of plus 3? Minus 3. So we'll do that first. We're going to treat this as if it was linear. So I'll say 2 times x minus 1 squared is equal to 18. What's the next one I'm going to get rid of? What am I going to get rid of next? Not the square. That 18, why do I want to get rid of the 18? It's on the other side of the equal sign. I'm trying to get rid of things on the same side of the equal sign. Now the -1's inside the parentheses. Well, you're throwing up 2 fingers in the air like you just don't care, but you can just say it louder. Yeah, we're gonna get rid of the 2 in front. If you're ever not sure, remember when you're doing operations, you do PEMDAS. But when you're canceling operations, you do SADMA. We just got rid of addition. Okay. The next thing we want to get rid of is either multiplication or division, which that would be the 2. Then it's going to come the exponent, and then even though this is subtraction, it's in a parenthesis, so that comes last. So the way we're going to get rid of that multiplying by 2, divide by 2. So x minus 1 squared is equal to 9. Now the time has come. We need to get rid of the square. The way you get rid of a square is the square root. On the left, what's left behind is x minus 1. What's the square root of 9? 3. But here's a big thing. Square root property says as soon as you introduce a square root that wasn't there before, you have to account for both sides. Think about it. What's 3 times 3? 9, right? But what's -3 times -3? It's also 9. So you have to put plus or minus 3. Has the yes? You're probably going to see plus and minuses, but my next question is, are we done? Has the variable been isolated? The whole point of solving an equation is to isolate a variable. Do you see that variable by itself? No. But the plus minus has made an appearance. So if you ever have an equation that has a plus or minus, that's what it means. It means plus or minus. And if there's still any more steps to come after the plus or minus is there, you're going to have to split it up into 2. So the same way kind of with factoring that we would break up into multiple equations, we're going to do the same thing here. Just instead of being equal to 0, this is going to be equal to 3, and then it's going to be equal to -3. Solve each one. This gives me 4. This gives me -2. So I have that x can be 4, and it can be -2. Right, Chris? 4 out of 5 Chris's agree. There's that one Chris that doesn't, though. Oh no, Mr. Romero on a Monday. Fractions? Are you kidding me? There you, sir. Not too bad. Let's just remember our goal today is we're going to isolate the variable. We're trying to get the variable by itself. This is not like before where we want to put everything on one side. We want to start moving terms to the other side. So what would I do first if I want to solve for this x? The reason why I'm allowed to do this is because the only x I have is the one that's being squared. What would I do first? The quicker you answer, the quicker I finish. Huh? Well, yeah, that's why I guess overall, generally speaking, I would like to isolate the variable, but specifically what should be the first step that gets me towards that. Okay, how am I going to get rid of the negative 3? What's the opposite of minus 3? There we go, plus 3 sounds good. Plus 3 on both sides. So 1 over 7 x squared is equal to 7. What am I going to do next? Do I get rid of the 1 over 7 or do I get rid of the square? Now it's the 1 over 7. Like, the square is going to come last. The only exception to that rule is when the square is outside of the parentheses. If there's ever anything inside of a parentheses, yeah, then that would come after the square. But if there's no parentheses, the square is going to come last. So I got to get rid of the 1 over 7. What's the opposite of multiplying? Dividing, but fractions can't be divided. So, somewhere mixed in with all the boring stuff in math, you learned about how to cancel out when you multiply by a fraction. It's called multiply by the reciprocal, copy, change, flip. If I were to flip a 1 over 7, what would I get? 7 over 1. So that's what I would do next. If I multiply by 7 on both sides, that's going to get rid of the 7's on the left. I'll get my x squared equal to 49. One step left to go, that's to get rid of the square. We learned today that's with the square root. So Jada, without screaming, can you tell me what x is going to be equal to? She did say 7, and I'm still pausing because she didn't give me a complete answer. Yes, Skyler. Thank you. Positive and negative 7 plus or minus 7. Anytime, it's something you really have to train yourself to not forget. Take care. Feel better? No. You just miss Ferris so much, but then he's not even here. Okay, let's do this one together. We did one just like it. What should be my first step? What do you think, Diana? Plus 2 will work. Good. So we get 3x minus given the parentheses square is equal to 16. I told you that the square usually comes last, except when there is the existence of a parentheses. If you're doing SADMAP, the E is going to come at the end unless when there's a P. So since that 3 and that 8 are snuggled inside that parentheses with the x, that's going to come at the end. I got to get rid of the square now. How do I get rid of a square? Square root property. So I will get 3x minus 8 is equal to what's the square root of 16? Plus or minus 4. Has the variable been isolated? No, it has not, but the plus or minus is there. Anytime the plus or minus shows up and you don't have a variable that's solved for, you need to split into two separate equations and solve them independently. 3x minus 8 is equal to positive 4. 3x minus 8 is equal to negative 4. Plus 8 plus 8. 3x is equal to 12. Divided by 3. X is equal to 12. Plus 8 plus 8. 3x is equal to 4. Divided by 3. X is equal to 4. Equation does have two solutions. It is 4 and 4 over 3. Chris, you wrote all that down? Yeah. What do you mean there was still a number with x? I don't understand what do you mean there was a number where? No, tell me. Like I just have like when there was here. And I divided it. Huh? Oh. What else? Yeah, the whole point is you gotta get x back up. Here, see if you guys can do that one on your own. Raise your hand when you got it. I've now done, even though this seems like it might be difficult, I've done two just like this already today. You definitely do not want to distribute. No. All we're trying to do here is isolate the variable. Raise your hand when you got it. What'd you get, Matt? Okay, let's see if that's the case. First step should be minus 4. So we get 2 times plus 2 squared is equal to 50. Next step should be to divide by this 2. You don't want to distribute it, Joanna. Even if you wanted to, you couldn't because the square takes precedence. You're supposed to square first, but we don't want to do that. We're just trying to isolate. So we get x plus 2 squared is equal to 25. Normally we get rid of the square at the end with this exception. When there's a parentheses, and even if it's in the parentheses, we would cancel out at the end. So let's get rid of the square now. The big, brand spanking new skill that you haven't learned before, that you're learning today for the first time, is that when if you have to get rid of a square in an equation by square rooting, square root property says that, yeah, square root of 25 is 5, but in an equation you have to put a plus or minus in front of it. If the variable's been isolated, then we're done. And it would, x would just be equal to positive 5 and negative 5, but the variable is not isolated yet. So we need to split this up into two distinct equations. One would say x plus 2 is equal to 5. One would say x plus 2 is equal to negative 5. So minus 2 minus 2, x equals 3. Minus 2 minus 2, x equals negative 7. Skylar, is that what you said? 3 and negative 7? I said 3, but I said 5. You said 5, but you didn't say 3. Here, I'll do this one. This should take you about 3.5 seconds. What'd you get, Donnie? Huh? X equals 56? Okay. Yeah. Eventually, but not at the beginning. Yeah. Plus 8 comes first. Yeah. And since x squared is equal to 64, what's the square root of 64? So the only way that you would think that you could possibly mess this up is if you forget to put a plus or minus. This equation has two solutions. Under normal circumstances, like if this was free response, like the way you would have had this in the fall, then yeah, you could argue where you would get like partial credit if you were to forget one of them, like if just like only put positive 8 and forget negative 8. But since everything I give you is multiple choice, it's more of an all or nothing proposition. Okay, see if you can do that one. Very similar to this would be like the fourth time you get one structured like this. Skylar, you did it already? You're ahead of the game? Good. Here we go, Chris. Here we go. Here we go, Chris. Here we go. Let's go, Chris. Let's go, Chris. Let's go, Chris. Let's go, Chris. Chris, 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 Chris. Ba-da-ba-dum, Chris. Somebody not named Skylar have the answer? You got a trade, what'd you get? 5 and negative 3. Skylar, do you agree with him? All right, so let's see. First step, Jade, is minus 1. So we get 2x minus 2 squared is equal to 64. Normally that square comes at the end, but since that square is on the outside and everything else is on the inside of the parentheses, the square is just going to come right down. You got to get rid of the square root. We drop the 2x minus 2 as if it was hot. But then you cannot forget that the square root of 64 is not just 8, it's plus or minus 8. Which means that since the variable has not been isolated yet, we've got to split this up into two separate equations. Plus 2 plus 2, 2x is equal to 10. So x is 5. I believe that is one of the ones that Trayshawn told me. And then plus 2 plus 2, 2x is equal to negative 6 divided by 2, and the other one's negative 3, which I believe is 10 also. -3. You have both of those, Joanna? No, how do you negative 3? Because that plus or minus means that you have to split this one into positive 8. Ooh. And these one, we did one kind of like this. It ended up being no solution, but I don't believe this one's going to give us no solution. Anybody want to try that one out? Besides, Donnie, you finished already? You got it already, Jade? Trey, you got it? You thinking about it? No? And did anybody have it? Sky? What'd you get?
I got 10 over 4.
No contraire, mon frere. Anybody else want to give it a shot? Diana? Joanna? Jade Anna? Kieranna? Well, here we don't have any parentheses to deal with, but the first step says variables on one side, constants on the other. So you have two choices as to, because we didn't have this every time, but even though there's two x's, since they both have squares on them, we should be able to combine them. But if I try to combine them on the right side, I'm going to end up with a negative in front, which is not the worst thing. I mean, it's easier to manage here than it was with factoring. But I would just say let's avoid that by doing plus 3x squared. So now if all the x's come to the left, I need to move the constants back over to the right. So we get 4x squared is equal to 100. Now, Tyler, based on the answer that you gave me, I'm assuming that what you tried to do next was to get rid of the square, which actually would work. If you did it right, it actually would have worked. If you try to get rid of the square, you'd also have to do the square root of 4, but let's not even cross that bridge, right? But what I tried to stress to you and convey to you is if you don't see a parentheses, let's get rid of the square at the end. So what you should be getting rid of now is the 4 by dividing by 4. 100 divided by 4 is 25. That's why there's 4 quarters in a dollar. And then the last step is to get rid of the square with square root property. And Jade, what is x equal to?
Plus or minus.
He told you. Plus or minus 5. Oh no, fraction. See, you can do that one. Anybody? All right, let's just do it together because I don't see this going anywhere. You got? You got stuff? What'd you get? Very good. Got it. Take that. He said 8 and negative 12. First step should have been plus 3. Well, 1/2 times x plus 2 squared is equal to 50. Okay? So Donnie, that should have been your first step no matter what, right? Now you got a little tripped up on how to deal with the fraction. The fraction does come next because both the fraction and the square are on the outside of the parentheses. And we get rid of multiplication before we do exponent. Now the way you would get rid of it, yes, is by flipping the 1/2 and giving you 2, but you got to multiply it. And you don't just multiply it on that side, you got to multiply it on this side too. So we got x plus 2 squared is equal to 100. You have to keep it 100. And then you get rid of the square by square rooting, Jade. What's the square root of 100, Jade? Plus or minus 10. So then when you split it, you get x plus 2 is 10, and x plus 2 is minus 10. So minus 2 minus 2, x is 8. Minus 2 minus 2, x is negative 12. There are two numbers that make this original equation true. It's at 8 and negative 12. Uno más, one more. So it should be simpler. Yeah, let's just do it together so we finish in time. What number am I going to get rid of first? Which two, the square or the multiplication? No, the multiplication. So here you would divide by 2. So we get x plus 1 squared is equal to 12. Then we square root J. What is the square root of 4? Plus or minus 2. But because the variable has not been isolated yet, we still have to get rid of the 1 and the plus minus is there. You split it up. Minus 1 minus 1, x equals 1. Minus 1 minus 1, x equals negative 3. So there's two solutions here. X can either be 1 or it can be negative. Any questions?